Hello and welcome to 2.7a. This is graphing rational functions. So one of the things that we're going to talk about in this is basically we have in math classes we talk about the difference between sketching and actual graphing. So sketching a graph is basically when you are just trying to get a ballpark of what the graph looks like. And a lot of times that's kind of useful for us for the fact that we can get a decent picture of it, but this isn't very accurate. When we ask you to graph it, there are things that we are looking for that will make it a little bit better and a little bit easier to tell what's going on. So for graphing, we're going to need precise points. We're going to need things that intercepts and holes and asymptotes and all of those things, where a sketch is just kind of like a freehand drawing of what we're looking at. So basically, in this section, we're going to talk about graphing, and so we're going to try to get all these rational functions, and we're going to get them graphed. And so we just need to make sure that we are getting all the points necessary. So we just need to think about our plan of attack on how we're going to come up with the points that we need for a rational function. And there's certain things that we have to have. So when you think about this, here are the things that we probably should have in most all graphs, especially rational functions. We need our vertical asymptotes. So I'm going to try to highlight these for us. We're going to have vertical asymptotes, horizontal asymptotes, and any holes that appear in the graph. And those will give us a pretty good idea. Then, of course, the x-intercepts, the y-intercepts, if there are any, and then points on either side of the vertical asymptotes, and then points around the x-intercepts and anything else that we can come up with. So make sure that you get down all of these. These are the things that we will be looking for when we go about graphing. So I have one example to graph, and we'll try to get all of these things to show up in the graph if we can. You know, they're not all going to be there every time, but these are the starting places that we are going to be looking for. And so if you can think of any others that might be necessary. So I'm going to split the screen here so we can kind of keep track of the things that we need. So we're going to graph this function, and we're going to include 5 key points. So these would be 4 of them, and then any asymptotes and things like that would be good too. So first thing, let's go through and look for vertical asymptotes. You'll notice that vertical asymptotes, remember, is when the denominator equals 0 as long as there's no factors that are in common. So if you're looking at this, vertical asymptotes, holes, and horizontal asymptotes would be where I would start all the time, because those are going to be our guidelines of where things are showing up. Well, you'll notice that there are no holes in this graph because there's nothing that I can factor out of both of these guys and cause this to cancel out anything in the denominator, anything in the bottom of the graph. So there are no holes. So there are none of these. Vertical asymptotes are when we set the bottom equal to 0, so when x equals 0. So that would mean we'll have a vertical asymptote at x equals 0. And then remember, for horizontal asymptotes, we talked about if the numerator and the denominator are the same, it is the fraction, the power of the numerator and the denominator. See, there's a 1 on the x and there's a 1 on the x on the bottom. So the degrees are the same between the top and the bottom. So we will get a horizontal asymptote at the fraction of 2 over 1, or in this case we'll call it 2. So now we need to look for x-intercepts, y-intercepts, and then points on either side of our horizontal and vertical asymptotes that we can get anything that we can basically find. So let's look for x-intercepts of this graph. And so x-intercepts means what? It means that y is equal to 0, because if we're looking for where we're crossing the x-axis here, that is where y equals 0. So when we're looking for x-intercepts, I'm going to set it up that 0 will equal 2x minus 1 over x, and I'm going to solve for x. Well, if I multiply by x on both sides, these x's go away, and so I'm still left with 0 equals 2x minus 1. So add 1, divide by 2, x comes out to be 1/2. So we have an x-intercept of 1/2 and 0. That's the only x-intercept that we have in this function. And I could plot that point, but I'll come back and make this graph bigger and plot all the points. Y-intercepts are basically when we make the x's equal to 0, So we would say y will equal 2 times 0 minus 1 over 0. Well, right now you can see that we're going to end up with y equals negative 1 over 0, which basically means no y-intercepts. And it's just because we're dealing with an undefined term, so we can't take negative 1 and divide it into nothing, so we're basically looking at no y-intercepts. And so at this point, so the graph isn't going to cross the y-axis, which should make sense because we have a vertical asymptote at x equals 0, which is this the y-axis. So that should make sense when we're looking at this, so that we shouldn't have had that, and we probably didn't need to do that. So now we're going to pick points on either side of our vertical asymptote and points around our x-intercept. So let's pick points around our vertical asymptote first. And so let's see, our vertical asymptote is 0. So I'm just going to pick some random points here. We'll say x and y. And let's pick a point. Let's say if we're looking at 0 as our vertical asymptote, I'm going to pick negative 2, negative 1. 0's out of the case because we already know that, 1 and 2. So I'm going to extend this page a little bit. And we're going to plug these guys into our function and find our values. Let me just make these a little bit bigger so they're easier to see. Negative 2, negative 1, 0. 0 is our vertical asymptote, so we don't really need that. And then 1 and 2. So I got my points around here. And so if I plug in negative 2 into this function, I get negative 5 over negative 2. So basically 5 over 2 is what we have there. If I put negative 1 into this function, I get negative 2 minus 1, which is negative 3 over negative 1, which would be positive 3. Plugging in positive 1, I get 2 minus 1, which is just 1 over 1, so we have a 1 there. And if I plug in 2, I get 4 minus 1, which is 3 over 2, which would give me 3/2 for this value down here. All right, so I got some points around my vertical asymptote. And these are pretty much points around my x-intercepts too, so we'll kind of use all of this to get our graph, and we'll see if this gets us a good enough graph of what's happening here. So let's go back to the full screen here, and so we'll start by plotting our vertical asymptotes. Our asymptotes, we have a vertical asymptote at 0. We have a horizontal asymptote at 2. So now I've got my asymptotes plotted. And so now I'll just kind of straighten them up a little bit. And now I'm just going to go through. My x-intercept I know is at 1/2 and 0. So we'll put a point at 1/2 and 0. There's my x-intercept. And then let's see. All right, go back down here. At negative 2, I'm at 5/2, which I believe is 2.5. So at negative 2, I'm at 2.5, somewhere right there. At negative 1, I'm at positive 3. So you can kind of see that my graph is looks like it's going to be approaching both asymptotes, the horizontal and the vertical asymptote over on this side. So probably enough information over here to get a sketch of what is going on. And then down here we have our point of 1/2, and then we've got the other 2 points of 1 and 2. At 1, we're at 1. So at 1, we're over 1, up 1. And at 2, oops, I put that at the 2 spot. At 1, we're over 1, up 1, which is right there. And at 2, we're at 3/2, so something like this. So again, we're going to approach both asymptotes. And there are 5 points that give us a pretty good sketch of what the graph is going to look like. So you could go ahead now and graph this on your graphing calculator and see that your graph would look like this, and just to check. But make sure that we get these 5 key points and the asymptotes on there to get our graph. So this concludes our video for 2.7, graphing rational functions. Remember, this is a graph we need points, not a sketch.